We are moving on to arc length and area of a circular sector. So if you joined the Zoom meeting, you already watched a video about how this kind of relates to the real world. So we'll kind of get into the math of it. So the arc length is it's a part of the circumference of the circle. So this piece right here is an arc, and we denote it with S, okay? So it's a part of the circumference of a circle, okay? This is our radius. We have a formula for this. It's S equals the radius times the angle in radians. So just kind of like a side note, the theta sign with a little r is the angle in radians. And if you see theta with a little d, that's the angle in degrees. Okay, so just kind of keep that in mind. It's just a little subscript r and d, and that makes a big difference when we're solving these. Some formulas only take the angle in radians. Other ones will take the angle in degrees. Okay, so just pay attention to that. So let's look at an example. Formula is relatively easy. I just take two numbers pretty much and multiply them together. That gets me my arc length. So example 1, we have a circle and the radius is 10. So r is 10, and it's intercepted by a central angle. So this means the angle inside of it. So if I kind of drew this one, and let's say this is my arc length, this piece right here, the angle is 7 pi over 4, and you're trying to find S, okay? So, and I know this angle is in radians because I see a pi there. Okay, so all we need to do is multiply. So S equals the radius times the angle in radians. So then S equals 10 times 7 pi over 4, which equals 70 pi over 4, and then we can type that in the calculator. I get 54.98 centimeters. So if I have the angle and the radius, I can figure out what the arc length is. Okay? So let's try one of these on our own. So the radius is 15, and the central angle is pi over 3. Okay, so try that one on your own. Okay, so this one's relatively easy. I just take the radius, which is 15, multiply it by pi over 3, which gets me 15 pi over 3, which type that in the calculator, we get 15.71 centimeters is the length of that arc. So if you're using the calculator, make sure you're using the pi symbol above the caret. So that's the pi symbol we're using for this, okay? So let's move on to an example. So now we know the radius is 7.5, and the arc is now 76 degrees. Okay, so we have this little degree sign. So we know the radius is 7.5, but the angle in degrees is 76. Okay, so what do we need to do first before we can plug it into the formula? Well, we need to turn this angle into radians. So 76 degrees to radians. Remember, we just take 76 pi over 180, and then in the calculator, we do 76 divided by 180. Math fraction, so we get 19 pi over 45. So my angle in radians is 19 pi over 45. And then I can just plug them into the formula. So S equals the radius times the angle in radians. I can solve that, multiply across the top, divide by 45, and we end up with 9.95 centimeters. Okay. So let's try one of those on our own. we have a circle with a radius of 20 and an angle of 113. So try that one on your own and then we'll go over it together. So my radius is 20, the angle of degrees is 113. When we try to convert it to radians, 113 over 180 doesn't reduce, so I leave it go, and then I plug that into my formula, and we get 39.44 centimeters, okay? So let's look at a space example. So we have the International Space Station. It's orbiting the Earth, and it's 400 kilometers above the Earth's surface. There's a station on the ground which tracks the ISS, and it's going to track it for 45 degrees. So as it's traveling around the Earth, the satellite's tracking it for 45 degrees, and then we want to know how far it traveled. So pretty much we're looking for this arc length for how far the International Space Station traveled. So again, our formula is just the radius times the angle in radians. So they tell me that the Earth is 6,400 kilometers, but we have the Earth plus this distance that the spaceship is above the Earth. So my radius is the 6,400 plus the 400, okay? So my radius is actually 6,800 of like the bigger circle, the white dashed line. And then my angle in degrees is 45. So I have to convert that to radians. So 45 over 180, 45 pi over 180, we simplify to pi over 4, okay? So then I just plug them in. S equals 6,800 times pi over 4. So we end up with 5,341 kilometers. Okay, so this has traveled 5,341 kilometers. You can see why that math is super important if we're sending people up to the space station. We don't want them floating around in space, kind of like the movie Gravity, if you ever saw that, which was terrifying. But we want to make sure they actually get to the space station so they're not just randomly floating out in space. Okay, so this math is super important. So let's try this one on our own. So it's the same situation, but now it's going to track it for 60 degrees instead of 45. So our radius stays the same, but now my angle in radians is pi over 3. So I take the radius times pi over 3 now, and I get 7,121 kilometers. So that's how far the space station has traveled. Okay, so now I'm going to show you this video. Hopefully you guys are familiar with Elon Musk. He created this video of kind of just something very futuristic that he hopes could happen in our lifetime. So I will show you that video. It's pretty amazing. It's about travel. So we'll need to know the arc length in order for the people in the rockets traveling to get to where they're going. So something like this could completely change the way we live our lives, right? We could live in Pennsylvania, but we could work in California. We could live in Pennsylvania, we could work in Europe if we could get there in 30 minutes, if that's our commute. So it could really, really open up some crazy, amazing things for us in the future. So that's kind of neat. So that, the math we're doing is very simple, but take the math we're doing and just maximize it. And that's kind of the math that goes into some of this rocket science stuff. All right, so back to the notes. We will do example 4. Example 4 is, I know kids kind of struggle with this in the past, so if you have questions, please feel free to reach out. We're looking at 2 gears, and I know the radius of the smaller one is 3 and the radius of the larger one, so I know the radius of both of them. I know that the small gear is going to turn 170 degrees, and I want to know how many degrees the larger gear's turned. So if this small gear is turning, right, that larger gear is going to also turn. So what happens is when the small gear turns, the arc length is going to be the same for both of the gears. Okay, so that's important to note. Okay, so the arc is same for both gears. That's going to help us solve this, because if I have how much the small gear rotates, and I have the radius, so I can find the arc length, and then I can work backwards. If I have the arc length, I can work backwards to find the angle that the larger gear is turning. Okay, so we always start with the small gear, and I'd like to find the arc length. So the radius is 3, the angle in degrees is 170, so the angle in radians is 170 pi over 180. Okay, we can simplify that if you want to, we don't have to. 17 pi over 18. So then my formula, remember, is just the radius times the angle in radians. Okay, so this is no different than what we just did in the previous example, but once I get that answer, it's 8.90 centimeters. So I know that for the large gear, this is my arc length. So if I'm using the formula S equals the angle in radians times R, or actually we kind of used it the other way. Sorry, so it's R times the angle in radians. So this is S. I just found what S is, so I can plug that in up here. R of the larger gear is 6.4, so I have 8.9 equals 6.4 times the angle in radians. Okay, so we can find the arc length, that's easy. Then I use it to work backwards to find the angle in radians. So we're just multiplying here. The opposite of multiplying is dividing. And then we get 1.3 equals the angle in radians. But we have to think about what the question is asking for. It's asking for the angle in degrees. But if I have an angle in radians, I know how to convert that to degrees. So we have to convert to degrees, and all we do to do that, so the angle in degrees is just going to equal 1.3 times 180 over pi. Okay, so we can do 1.3 times 180 in the calculator, divide by pi, and we get 74.48 degrees. Okay, so that's my final answer. So these problems are a little bit longer, but if you understand that the arc length is the same, the arc length formula is very easy, and I have all the information from the small gear, and then I just use it to work my way backwards for the large gear. Okay, so let's try one of those on our own, and then we can go over that together. All right, so small gear, we write the information, convert the degrees to radians to find the arc length. Okay, so we have enough information to find the arc length of the small one, which is 8.38. I'm going to plug that into the arc length of the large one because that's a small gear rotates, you know, the gears, the teeth are connected so they travel the same distance. So I set up my formula with the arc length and the radius of the large gear, divide by the radius to get the angle in radians, and then convert that angle by multiplying it by 180 over pi to get 72.77 degrees. Okay, so you'll see gears a lot in like clocks and cars and things like that. So this math is kind of going on behind the scenes when you're working on cars, or if you ever work on clocks or anything with gears. Okay, there's lots of machines that use gears. Okay, so moving on. We have two formulas here for the area of a circular sector. So these are relatively easy. Make sure you're writing them down. One of them is radians, one of them is in degrees. Notice this is 2 pi, this is 360. So pi r squared is the formula for the area of a circle. So then I'm just going to take a fraction of the circle. Okay, so that's kind of all we're doing here. These formulas are relatively easy to use. Let's look at this example. So we have a single slice of pizza. The entire pizza has a 14-inch diameter, which means, what's my radius? Radius is 7, and it's cut into 6 equal pieces. So if it's 6 equal pieces, we know that there are 360 degrees in, so we're for finding the angle in degrees. There's 360 degrees in a whole pizza. So if I take 360 divided by 6, that's going to equal 60 degrees. Okay, so we can figure out what that formula or what that degree measure is. Then I can plug it in. So this is going to equal, this is in degrees, so I'm going to use the degree formula. So it's 60 over 360 times pi r, which is 7 squared. So we just plug that in and we get 25.66 inches squared per slice. So if you're ever curious the area of one of your slices of pizza, you can solve it this way. Another thing you could do is to find the area of the whole entire pizza, assuming it's cut into 6 equal slices. Find the area of the whole thing divided by 6, okay? That is one way to get away from this formula, but you'll see in the next example we'll need the formula, okay? So I'd like you guys to try the next one on your own, and then we'll go over it together. So if we're using the formula, my radius is 8 because it's half of 16. The angle in degrees is 45 because 360 divided by 8. Plug that in, 45 over 360, pi times 8 squared gets me 25.13 inches. You could have found the area of the whole pizza and divided it by 8. You still should have gotten 25.13 inches squared. So you're free to do whichever method you want, but I just wanted to get you guys comfortable with using the formula, okay? For this last example, we're going to look at a sprinkler head. This particular sprinkler head rotates at 90 degrees. So we kind of, if you think of how a sprinkler works, it shoots the water out, and this one says it has enough pressure to keep a constant 25-foot spray, and then it kind of slowly moves its way, and it only goes 90 degrees, okay, and then it goes back. So it just goes back and forth between 90 degrees. So I'm trying to find the area, so this area right here that this sprinkler covers. Okay, so we can use our formula. They give me the angle in degrees, so we know which one we're going to use, and then the radius is 25. So when we're using the formula, we are going to use this degrees formula, and I'm going to take 90 over 360 and then times pi r squared. My radius is 25. Okay, that we can type in the calculator, and I end up with 491 feet squared. Okay, so as long as we have this picture, this one should be relatively easy. Okay, also says round to the nearest foot, so that's what I did here. All right, so try this next one on your own, and then we'll go over it together. So they now give us an angle of 130 degrees. The radius is 30. So I plug all of those in, type this in the calculator, and we get 1,021 feet squared. So that's the area that that sprinkler is going to cover. Okay? So then your homework tonight is going to be page 147, numbers 3 to 10, and then we got a bunch of singles here. So 28, 33, 41 to 44, 49, 50, 55, 56, 61, and 62. Okay? So try that. Please reach out to me if you guys have any questions.